All right, finally what we're gonna do is put all of those features that we've talked about with these rational functions together and try to use all of these concepts to draw a pretty decent graph of a rational function. So what we've got here is, you can see it's a y equals a polynomial over another polynomial. I chose not to go with function notation, so it doesn't really matter for all the work that we're gonna do. And yeah, what we're going to want to do is go through and look through all of the different stuff we've been looking at. We want to look at the signs to see where this thing is positive or negative. And we want to look for zeros, vertical asymptotes, horizontal asymptotes, and any holes potentially. Horizontal asymptote is kind of its own thing, so I'll look for that first. Yeah, why don't I look for that in red, and I'll call that, shouldn't do green. So a horizontal asymptote doesn't require any type of factoring. If you remember, what we do is we look for the leading coefficient, or the leading term over the leading term. So if you recall, these guys have the same degree. So what we'll do is get the y equals, we take the lead coefficient of the top term, which would just be like a 1, divided by the lead coefficient of the bottom term, which is also 1. So y is equal to 1 over 1, which is just equal to 1, obviously. So that's going to be our horizontal asymptote at y equals 1. So it's pretty quick to figure that one out. And so for the rest of the things that we have to do, we are going to actually want to factor everything. So I might as well do that now. So we'll factor the top and the bottom. Right, everything else, zeros, vertical asymptotes, and holes, they all depended on how things factored. So I'm just going to rewrite this. It'll be y equals, so the top should be x minus 3 squared. And the bottom will be x plus 1, x minus 1, that difference of squares. And so if we find our zeros, so remember the zeros are where the top is equal to 0. And so that's just going to be x minus 3 squared equals 0. So we have zeros basically just at 3. Sorry, I put it in point notation. So the 0 is, there's only one 0 at x equals 3. And I also just kind of jumped into it. Like there's nothing to simplify here, so I could just sort of jump right into all of these questions. My vertical asymptote. And so remember, in that simplified form, that's where the bottom is equal to 0. So that's where we're going to have x plus 1, x minus 1 equals 0. So x is plus or minus 1. So I'm just going to put a box around all of this information. I'm going to need it all to put my graph together. And so the last thing I'm going to do is maybe look at the signs of the function, because that's going to tell me where everything actually occurs. And so that's that table that we've been doing all along. All right, so I'm going to set up my table. I need, if you recall, I need the list of all the zeros from the top and the bottom. So this whole list of the 3 and the plus or minus 1. All of those are places where the sign could potentially change. So I'll list all of them in increasing order, -1, 1, and 3, and then set up a table. And in this table, I'll write all of the factors on the left. So all of the factors, when this thing is simplified, I've got an x minus 3 squared. Don't forget that power. And an x plus 1 and an x minus 1. So these things all multiply or divide to contribute to my function y. And then we just check the signs as we go across. So this is a square, so it's positive everywhere except it's 0. X plus 1 is negative, and then it switches into the positive. So 0 plus 1 is positive, 2 plus 1 is positive, etc. And x minus 1 will be negative until 1, and then switches over at 1. You'll notice that we have something with a multiplicity 2 there, so that should mean that the sign won't change at that 0 of 3. And if you look, we have 2 negatives make a positive, 1 negative makes a negative, 3 positives and 3 positives. If you look, you'll see we don't have a changing sign at x equals 3, so that's something we're going to have to be mindful of. And yeah, so from here we just kind of put everything together. So that'll be the last step, and there's going to be a lot going on here, so you have to be really careful. So I'll get some kind of a scale down. Let's see, so I need some x's. I need plus minus 1 and 3. So there's minus 1. There's plus 1, 2, 3, 4, 5, 6, 7, 8. And I can do a few more points to the left, but I don't really have to be very specific back there. I do need a y-axis for this because I've given a horizontal asymptote at 1. So I need to know where that actually occurs. Maybe the rest of the y values won't be super fixed, but I do want to know where that one occurs. So step 1, I'm going to draw this horizontal asymptote at y equals 1. So remember, we can usually draw these with a dotted line, because the dotted part of the line will tell us that it's actually not a feature of the graph. So there's my y equals 1 horizontal asymptote. As mentioned before, horizontal asymptotes for rational functions will work on both sides. And so yeah, I'm just going to get the dotted line so it will make sure it's very clear that that is not part of the graph. And yeah, so I'm going to just keep going through and drawing all these sort of skeleton features of my graph. Next up, I've got the zeros at 3 and 0. So I can plot, yeah, it's just 1, so 3 comma 0, I should say. So yeah, we just have that 1 point right there for the 0. So my curve has to go through that point. And the vertical asymptotes, which I'm going to do in red, are at plus or minus 1. So I'll go through here and here. I'll just label those. Remember, they are x equals features of the graph, so they get they're going to be vertical lines. All right, and I'll just make them dotted. All right, so those are the 2 vertical asymptotes, dotted lines. And so what we're going to do now is I'm going to label everything with those signs. So I'm just going to use those sort of brackety notation to indicate what goes where. So plus means it's going to be above the x-axis from everywhere to the left of -1. And then from -1 to 1, it's going to actually come and be below the x-axis. And then from 1 to 3, which will go right here, so it'll be plus, plus, and minus. And then 3 onwards, that'll be plus as well. So those orange things are just telling me where to draw the curves. And yeah, so what we can do is just sort of draw this left to right to fill everything in. For the graph, we're just going to put a curve everywhere. The only place where this is not defined is at 1 and -1. So I need to make this curve that I draw hit all the values. And so the leftmost thing that we need to think about is our leftmost end behaviors, what's going on as we go towards negative infinity. And we know that we have this horizontal asymptote at y equals 1. So that tells us what's going on out there. So I'm going to use it. I'm going to draw this arrow just kind of flat along with that horizontal line. And that's the first thing I need to do. If I look left to right as I am investigating this graph, I see that the next thing I encounter is this red dotted line. So I need to use that. So my curve needs to either go down the vertical asymptote, or it would go up the vertical asymptote. It can't do both. Yeah, so it's a function. I can't have both of these things here. What I've drawn right now completely fails the vertical line test, but rationals are going to go either up or down both sides of that vertical asymptote. This is where we use the sign to figure out which one, because I know that it's positive in this region. It can't go down because then it's getting into the negatives. So this down here is a big problem. I can't have it do this. So I'm going to actually just erase that portion of it because it can't go down. So that thing wasn't quite right. So it's actually got to go up to stay in the positives. And so that brought me to the left side of that red dotted line. Now what I need to do is start on the very right side of that dotted line. And again, it's either got to go up as we move towards it or down. And it's all about the sign. Again, I can't have this portion of the curve up at the top because then it's in the positives. So I have to choose one of them, and it's certainly not this one. So I'm going to erase that. And so I know I'm down here at the bottom, and then we just kind of keep using that logic to draw the rest of this. Again, as I move to the right now, it's either going to go up. Well, it can't do that because it shouldn't ever be positive there. So what it actually has to do is come down. I could actually figure out what the height is of that value pretty easy by just actually plugging in 0 and getting out a y value. It actually would be -9, but I don't really care about what that actual value is. So don't worry about that. It's more important to be on the correct side of the x-axis. So we start on the very right-hand side now of this vertical asymptote. Again, we have to start from the top. We can't start from the bottom because that's in the negatives. Now as I move left to right, I can't just do this because I have a feature that I've skipped over. There's a point there. That's the next thing I need to think about. So I'm going to go back a step. I actually have to go to that point. And I know that it stays positive, so it's got to kind of smoothly go through that point. And then now, if I'm looking at what's happening here, as I make my way to the right, I can't just do this willy-nilly. It's not going to go up like that forever because I have that horizontal asymptote. I need to be mindful of the horizontal asymptote. So I could do something like this, maybe. That would be perfectly fine. You might have heard somewhere along the way that a curve cannot pass through a horizontal asymptote. That is, well, actually, you probably heard that a curve can't pass through a vertical asymptote and then just assume that it can't pass through a horizontal one. It totally can. It's completely fine for this curve to pass through the horizontal asymptote here. There's no problem with that behavior. So this is what the graph should look like. I'll just kind of explain why you might have heard something like that before. A function actually can't pass through a vertical asymptote, just a vertical one. It's fine to go through a horizontal one. In the case of a vertical one, let's say we know it goes up like, I'm going to actually do that. Let's say we know that the curve is supposed to go up here somehow. And if it's coming in from the left and it crosses through it, well, on one of these sides, it has to go up to that arrow. So it's going to have to do that continuation from over here on the right. And in order for it to go up to that arrow, it has to, if we've crossed over like that, it's going to have to double back and do something like this, which fails your vertical line test. So a function cannot cross through the vertical asymptote. Non-functions can, a function cannot. It's just because the only way it happens is to break the rule of function. Horizontal asymptotes are fine though, so don't stress about those. So yeah, so this is one fairly involved graph. But yeah, you'll always want to get these things started by just sort of drawing a skeleton of your two types of asymptotes and your zeros, and then connect the dots in a way that hits all of the features. So we're going to do another example, and that should wrap up the graphic. Okay, so for this one, we've got, again, another rational function. F of x is, and so we've got this cubic on the top and a quadratic on the bottom. Just as before, the first thing I'm going to look at is the horizontal asymptote. So here I've got that the degree of the top is in fact bigger than the degree of the bottom. And so that tells me that there's no horizontal asymptote. If you recall what we're looking for, the top grows too fast for this thing to flatten out. And as always, I'm going to factor this for everything else. The top maybe looks a little scary because I have that cube on the top, but notice I can take an x out of everything. So it's we don't have to go through all those techniques from before. So I'll have x times x squared plus 2x minus 3 over x squared minus 3x plus 2. And so this should factor to x plus 3, x minus 1. And the bottom is x minus 1, x minus 2. And so notice that we do get that cancellation of the minus 1s. And if you recall, that tells us that there is a hole. So I'm going to write this one out in purple. So there's a hole. So there's a hole at x equals 1. And the y value that goes with it is going to be found by plugging the 1 into that simplified version. So y is going to be equal to 1 times 1 plus 3 over 1 minus 2. So that should be minus 4. So the hole is going to be at the coordinates 1 and minus 4. So right, it's a removable problem. It's a really simple problem. And so I'll refresh you guys on how we're going to graph this. For the most part, we're going to ignore that fact and then put it together later. So we've got the hole, and so what I want to do next is get my zeros. So those are going to be zeros across the simplified top. So we've got that cancellation. We're going to ignore the fact that 1 does make the top 0 because it's been canceled out. And so this is going to be where x times x plus 3 is 0. So this is going to be at, my zeros are at x is 0 and minus 3. And then the vertical asymptotes, those are going to be the zeros of the simplified bottom. So again, not x equals 1. That's a different feature. And so that's going to be where, yeah, that simplified bottom is just x minus 2 is 0. So my vertical asymptote is at x equals 2. And then I'm going to, just as before, we'll investigate the signs. Because the x minus 1s completely cancel, I could either not write them or write them both, and they will sort of cancel each other out, right? If they're both negative, it's going to switch to a positive. If they're both positive, it's obviously positive. So they don't really contribute anything. I'm going to leave them out of my table. And so the things that we do want are going to be those zeros in the vertical asymptote. I could put the 1 in there if I want, but it's not, like, I'll show you what happens. It's kind of a waste. So let's say we put in the minus 3, 0, 1, and 2. I might need a little bit of extra space here because I'm going to have x minus 1 written twice. And so I've got x, x plus 3, x minus 1, x minus 1, and x minus 2. And so x is negative until 0, and then it's positive. X plus 3, we'll switch over at negative 3. X minus 1 switches over at 1. And then, of course, x minus 1 is the exact same thing. So it's going to do the exact same thing. And you can see all those negatives just cancel each other out. And then x minus 2 is going to switch over at 2. And so I've got 5 negatives make a negative, positive, negative, negative, and that should be a positive. So yeah, that x equals 1, we don't get a behavior change across 1. And so we should be pretty good to graph this now. So first of all, what we're going to do is completely ignore the hole right now. I'm just going to start by getting some kind of scale here. Actually, you know what? Maybe I can just draw that hole. It'll help me guide the points a little bit, so I guess it doesn't hurt. I need, what, negative 3 up to 2. Yeah, those a little bit wonky looking numbers, that's okay. One, 2, 3, 4, 5, 6. Go a little further. All right, and yeah, I'm just gonna put all these features down that I found. I don't have a horizontal asymptote, so I don't get that green dotted line. I said I found that hole, so I guess I could just go ahead and label that. So the hole is at 1 and negative 4, so that's gonna be right here. And the zeros are at 0 and negative 3, so I'll have a 0 right here, and at negative 3. And my vertical asymptote at x equals 2. All right, and so yeah, make it dotted so that we know that it's not really there, just like that that pink circle's not really there. And I'll label my signs. You don't have to do this part, but I just think it adds to the visual while I try to teach this. So everything to the left of negative 3 is in my negatives. It's positive from negative 3 to 0. And then it's negative from 0 to 1. And then negative from, oh, sorry, I went too far there. Right, so that actually should just go here. That's my negative. This is also negative, but I do want to be careful because it does skip over that 1 point, and then it's positive after 2. And so that should be enough to get my information here. So I know those signs, which tells me my end behavior. Because there's no horizontal asymptote, I want to make sure this thing doesn't flatten out. And so what that means is that the curve is either going to go up and left or down and left as x goes to that negative infinity side. And because it's in the negatives, I know that it's going to follow that down and left behavior that I drew there. So I'll just keep that in that green so you can see where that comes from. We can do the same thing on the far right too if you want to go over there and use that piece of information. There's no horizontal asymptote, so because this is positive over here, I do know that it's got to go up and to the right, so something like that. And then to draw the rest of this, yeah, I just make my way to feature. So the next feature that I'm hitting on the right here is that point, so I'll just go up to that point, and then I know it goes through it, and then on the positives to the next point. All right, and we'll go to that point, and then again, the next feature we hit on the right is going to be that open dot. So we're going to have to get towards that. We know we're going to be in the negatives, so I'll just go towards that point. I'll use that point, And then if you look, see, we're still in the negatives after. So when you have a hole, the curve should just sort of go through that hole, but sort of skip over that point. When we go to the vertical asymptote, it goes straight down. And then on the right-hand side, I'm going to come down from the vertical asymptote because it's got to stay in the positives. And then when I look over, I see, okay, I got to use that green arrow because the lack of horizontal asymptote told me that was there. So I'll just make my way up to it. And then that should basically be what that function looks like. So that's a pretty good idea of it. Yeah, that's about as hard as some of these will get. Sometimes I'll ask questions where I actually give you everything already factored, and then yeah, I give you all this information, which just skips most of the actual analysis work. I like those for test questions because you can't just plug it into a graphing machine to do it for you. You actually have to do, you have to know what all these things mean. So look forward to that. But yeah, that's graphing rationals.